So today we're going to move a little bit away from circles and we're going to talk about parabolas. Now, a parabola, if you remember from algebra, is the graph of a quadratic function. They look like the letter U. You can see one right here. Now, we're going to talk about a different way to think about how to make a parabola. If you look at this diagram, it's going to kind of help us think about what a parabola really is geometrically. Notice that there's this big dot in the middle, this point, and that point is called the focus. And then we have a line down here, which is often the x-axis, and that line we're going to call the directrix. So we have two new words. We have the focus, which is the dot, the point, and we have the directrix, which is the line. Now, a parabola really is just all the points that are the same distance away between the focus and the directrix. They're equidistant from these two things. So for example, this dot is the same distance away from the point and the line. So it's on the parabola. Now, I realize that my diagram isn't perfect, but just imagine that, like, for example, this one up here, this distance here to the focus is the same as this distance here to the directrix. And if that is the case, that means this point is on the parabola. Same with this one. This distance from this point to the focus is the same as the distance from this point to the directrix. That means this point is on the parabola. A parabola is really all the points that are the same distance from the focus and the directrix. And changing where this focus is will change the shape of the parabola. In this situation, so let's look down here at this example. You can see that this is the focus and the directrix is down here. It's the x-axis. This point right here is the same distance away. It's 2 units away from the focus and it's 2 units away from the x-axis or the directrix. All of the points that meet that condition, the same distance away from this point and this line, would be a point on the parabola. We can use that information to determine if a point is on the parabola. If it is the same distance away from the x-axis and this point, then that means it must be on the parabola. If these distances are different, that means it's not on the parabola. So let's look at our first point. We have this point, 11,5. Is this a point on the parabola? Well, that means we need to find the distance from the directrix, which is down here, and the distance from F, which is right there. And then if those two match, we know it's a point on the parabola. If they don't, we know it's not on the parabola. So let's do this one first because this one's pretty easy. The distance from the point 11,5 to the x-axis is 5 units. It goes straight down. We can just count them. 1, 2, 3, 4, 5. That is really just going to be whatever the y-coordinate is because that tells you how far it went up. The little bit trickier one is this distance right here. I'm going to use some patty paper on this. I'm going to see if you can, yeah, I guess that works. Good. Okay, so we have F. We have our point. Okay. To get from one to the other, we go up 1 and over 5. But we want to know what the straight diagonal distance is. We don't want to go up and then over. So really, we want to know this distance. Now, some of you might be thinking right now how you can find that distance. We know if this is 1, and if that's 5, and we know this is a right triangle, hopefully some of you right now are saying in your heads, oh, I can use the Pythagorean theorem to find out what that distance is. And that is exactly what we're going to do. So I'm going to take this triangle right here from my graph, and I'm going to just kind of draw it down here. So I'm going to redraw it Okay, so I have F, that's 1, that's 5. And I want to know what the distance is between F and 11.5. Not the up and over distance, but the straight there distance. And if this distance right here is the same as that, I know it must be on the parabola. If it's different, I know that this point must not be on the parabola. Maybe it's just really close, but it's not quite on. It might just be a little bit off it. So let's look. I know if this is my right angle. The Pythagorean theorem would tell me that 1 squared plus 5 squared would equal x squared. So 1 squared plus 5 squared equals x squared. So 1 squared is 1, 5 squared is 25 equals x squared. 1 plus 25 is 26 equals x squared. So I square root both of those. And I get, if you do the square root of 26 in your calculator, you get that x is 5.1. Since 5.1 and 5 do not match, that means that they are not the same, which means that this point, if it's 5 to get to there and 5.1 to get to there, this point is not on the parabola because points on the parabola have the same distance from the point to the line and the point to the focus. So, not on parabola because 5 does not equal 5.1. Okay? Now let's try this again. What about this point down here, 1410? So we have this point, 1410. Is that one on the parabola? I have it marked up here. And if you go straight down, the distance from that point to the directrix, or in this case, which is the x-axis, is 10 units away. Really, it's just the y-coordinate because that's how far up you had to go. So going straight down, it's 10 units away. The distance from F, we're going to mark that out on here. Going up, going over, we had to go up 1, 2, 3, 4, 5, 6. We had to go over 1, 2, 3, 4, 5, 6, 7, 8 units. And then we don't want to know the up and over distance, though. We want to know the straight there distance. So we want to know what that is. So we have our right triangle. We can use the Pythagorean theorem again to find that distance. And if it equals 10, we know that this point must be on the parabola. If it doesn't, we know that it's not. So let's take a look at that. So we have... Okay, I'm just going to redraw my triangle from my patty paper. So 6, 8, x, and I need to find that distance right there. So I'm going to say 6 squared plus 8 squared equals x squared, just using the Pythagorean theorem. I know 6 times 6 is 36. I know 8 times 8 is 64 equals x squared. 36 plus 64 is 100. Square root both sides to get rid of the square. And I know that the square root of 100 is 10. So because this distance was 10, and because this distance is 10, since they're both 10, I know that this point is on the parabola because 10 equals 10. And that is more of a geometric way to define a parabola, and it is a way that you can determine if a point is on a parabola or not on a parabola. Just to summarize, if you have a point, the distance from the point to the focus and the point to the directrix, if that's the same, it is on the parabola. If it's different, it's not on the parabola. Go ahead and try the practice, see how you do. Hopefully, if you have any questions, you can make our next Google meeting, or you can email me questions and I can help you. Remember, you can take the practice multiple times to see if you can get a 100%. Good luck.